Hi, this is Peter with CalcBook, and today we're going to be looking at another timber connection design, and specifically looking at a wood screw in combined loading. Just a quick recap, right? We are using the National Design Specification, also known as the NDS, and we have two documents that we use, the NDS spec and then the NDS supplement. So the NDS spec, right, gives us the overall design procedure, our capacity equations, adjustment factors. We can choose whether we're looking at lateral or withdrawal, and then our dowel type. So it's either a bolt, lag screw, wood screw, nails or spikes, drift bolts, and drift pins. That's what we're going to be focusing on for these connection videos. The supplement is a bit more for member design. It has different reference design values, shape properties, that sort of thing. We do use it sometimes for connections, but again, that is mostly used for member design. So for this video, right, we're going to be looking at both lateral and withdrawal for a wood screw, so a combined loading effect on a individual fastener. So our problem statement for today, right, we are going to be verifying the connection giving the following parameters. Right, we have a wood screw here that has a steel side plate and a wood main member. We have a wood screw with a length of 1.5 inches. We're going to be figuring out what size or what diameter that screw is going to be to make this connection work. It's a 1/4 inch steel side plate member, 2x4 flat Douglas fir larch main member, dry fabrication condition and dry service condition, and we're going to be utilizing LRFD loading for this design example. And our loading, right, we have a tension or a withdrawal load of 175 pounds, and this is from earthquake loading, and then we have a lateral earthquake loading of 275 pounds. So let's go ahead and open up CalcBook and we'll get started on the design. All right, I've got CalcBook open now, so we'll go ahead and click into our timber design module, and then we'll go ahead and click into our connection design, and we'll click into our combined lateral and withdrawal load. Get that loaded up. So the first thing we want to do is select our dowel type, right? Our fastener we said is going to be a wood screw. The wood screw size or the screw number, we didn't say, right? We're just going to start with a number 10, and we'll see where that puts us, and then we come back and adjust it. Our dowel bending yield strength has already been populated, but if you need a reference, right, you can pop this open. Table I1 will give you the reference value for that. Our total length of fastener is 1.5 inches. And our main member is going to be a Douglas fir larch, we said, DFL. The angle between the direction, right, don't get this confused with our combined loading angle, right? That will be automatically calculated by the load. This has to do with sort of the planar direction which the load is applied. So in our case, it's 0 degrees. Our main member thickness here is going to be 1.5 inches because it's a 2x4 flat. Our side member, right, we said is a metal or a steel plate. And we're going to say it's a hot rolled steel plate, and it's going to have a 0.25 1/4 inch thickness. Right, then we have some additional adjustment factors here. We are not in the end grain. We said we were dry for both service and fabrication. No temperature issues here. And our time effect factor, we can actually take advantage of this. Because we are using an earthquake load, right, we can take advantage of the 1.0 time effect factor. So go ahead and toggle this to 1.0. And I think that's all of the capacity side of things. So we go ahead and click into our demand, right? And we've got a withdrawal, the tensile load of 175 pounds, and a lateral or shear force of 275 pounds. All right, so we can see we are over by about 10% there, 1.09. But let's go ahead and jump through the calculation. And we will see where we are, and then we can adjust from there. So one thing I wanted to point out here, right, is that we have two different diameters, right? We have the nominal diameter of the wood screw, which is 0.19, and then we have the root diameter, which is a reduced diameter of 0.15. And this comes into play whether you are looking at withdrawal or bearing. You want to be sure you use the correct diameter for that calculation. So our combined load, right, which is just going to be the magnitude of the withdrawal and the lateral. So we just have to square root some of the squares there of 325 pounds. And then we get into our capacity. So we have some preliminary calculations that we need to run, right? We need to figure out what the length of that tapered tip is and reduce that from our embedment or our penetration. So we get the length of our penetration, which is that equation there, the total length minus the thickness of the steel plate, the side member, and then minus that tapered tip. And then we want to check that against the total thickness of the main member, right? If we have a long fastener that's going to protrude, right, we don't want to be using the total length of the fastener, just limiting it to whatever is embedded in that main member. We figure out our angle between the tensile and the shear load. Our dowel bearing length we figure out. Our side member, right, which is the complete thickness, 0.25. Then we want our dowel bearing strength for the main and the side member. Then we have our RE, RT values, and then our different K values that all go into our nominal yield mode capacities, right? This is all for lateral. So we have our different failure modes for lateral, right, our Z values, and we go through and check all those different yield modes. And then we get a controlling nominal lateral strength of the dowel type fastener of 160 pounds. And we have a nominal withdrawal value of 135 pounds. And note there, this is using the full diameter 0.19, where the lateral bearing uses the reduced diameter D sub R. Then we check our adjustment factors. Right, for us, we did not have any adjustment factors. Our moisture content is 1. No group effect, no geometry effect. All of that is going to be 1. And then we have our final connection capacity, right? So we have our Z prime, which is our lateral strength, and our W prime, which is our withdrawal strength. And then we run that through equation 12.4-1 of the NDS spec. And that gets us a total adjusted design value for a combined lateral and withdrawal loading of 298 pounds, right, which we are over by about 10%. So we can just go back here and we can just up this size to maybe a number 12, right, and there we go. So 0.99, that gets us the correct screw size for this connection. So that is a combined lateral and withdrawal loading connection for a wood screw in CalcBook. We hope you enjoyed the video. If you have comments or suggestions for other videos, please let us know in the comments below, and we'll see you next time.